Alright, we are live. I'm going to give it a minute or two. I know that most people, or there's a handful of people that are stuck out trying to get to the school and back. So we will give it a minute for people to join, but I'm not expecting as high a numbers as we normally have. Um, Hope everybody went and got their test. If you live near the school, there's still some time. Leave now. Go get your test. Uh, the time is between 1 and 2 to pick up your tests. There are two of them. One for the stuff we did last week, one for the stuff we're doing this week. Uh, we're going to go through this. I'll probably do a couple circuits. I might go live in between lessons. I'll post it in Discord. Just to work some random circuits, not actually go over a lesson, but just work some circuits, just to get that up on the YouTube channel, and you guys can visit with that. Not sure. Maybe I'll do it tomorrow. Not. Uh, Maybe early tomorrow. I'll work some circuits. I'll post it in the YouTube channel whenever I do. Okay. So let's go ahead and get started. Viewership went down by 1, so that's a good sign. We'll get started. Quit. We'll do that later. When two batteries are connected as a series additive power source, they provide voltage that is less than either of the batteries connected by itself. So, series additive. Additive means it adds. So, this is a case of, let's clear this. I could have done this before y'all got here, but I like making y'all watch me work. Okay, series additive. That would be, and I'm going to draw the schematic version of batteries, which is that. So, of note, if it isn't marked, the side with the short line is negative, and the side with the long line is positive. So this would be series additive, meaning both batteries are pointed in the same direction. So if this was 6 volts and 6 volts, they would add together, and your E total would be 12 volts. But if they were series subtractive, meaning oh boy, meaning that you have the batteries pointed towards each other, meaning the common terminal, or the like terminals are connected, so negative to negative or positive to positive. It can be at subtractive if they're pointing away from each other as well. So this would also be subtractive. Uh, so it'd be negative, positive, positive, negative. So these are both subtractive. So these are both subtractive. So if these were 6 volts and 9 volts, your E total would be 3 volts. In a series circuit, yes, Wazy, I am live streaming. Did I not? Did I not? Yeah, series circuit series. That's this one. I just posted it. Sorry, I was getting a question whether I was live streaming yet. So I was making sure I had shared it to the Discord server, and I had. All right. In a series circuit, the total or sum of all voltages dropped across all of the circuit components is equal to the source voltage. So yes, that is, and we'll see some circuits. I'll cover that in a minute. As current increases in a series circuit, the voltage dropped across each load in that circuit will increase. So all the voltage, let me put this on the screen. Kirchhoff's voltage law. So there is a good video from Khan Academy that I would normally show in class. Definitely go and watch that. That's a great video. I can't find. I'm not seeing a spot that shows it like pretty detailed. So what Kirchhoff's voltage law is that the sum of the voltage drops across a circuit will equal 0. So let me get rid of that and that. So let's finish out this circuit. That's a box. That's a. Let me try a little bit harder on drawing these resistors. That's awful. Oh God. There's a line between looking at what you're drawing. I mean, I could just bring this closer. Anyway, if you're just measuring voltage drops, let's say if this one had a voltage drop of 3 volts. So this would be positive 6 volts and positive 6 volts. If this one had a voltage drop of 3 volts, we know that this other one has to have a voltage drop of 9 volts. So the sum of the voltage drops around a circuit, so it'd be plus 6 minus 3 minus 9 equals 0. The sum of the voltage drops must equal 0. Or you could say the sum of the voltage sources, so 6 plus 6, and the sum of the voltage drops, 3 plus 9, must be equal. So going back to our question, if you increase the current in a circuit, the voltage has to go up everywhere. And same concept as before, if we change these to, let's go super janky, 8 and 8, well, these are both going to go up as well. But this will be still the higher of the two voltages. Let's say this is 5 ohms. Ooh, I'm getting into some, let's see. This would be, forget that. I'm not going to put too many numbers to it because then it makes the math not work right. And that would just confuse people. All right. Calculate the voltage that would be applied to a circuit connected with power sources as shown. Okay. So how much voltage is being applied to this circuit? Well, we have two 6-volt batteries connected in additive. You can see that they are connected negative to positive. They are both pointed the same direction. So the current flow is going to be going in the same direction. So if this was the circuit, the current flow through this battery is going that way, and this battery is going that way. So the current total in the circuit is going like that. They are adding together. And the answer will be 12. Most everybody got it. I don't know how you take the numbers you were given and get 20. I can see how you can get to 6 from the numbers you're given, but don't know how you get to 20. All right. So let's check the voltages with the battery sources shown here. Let me see if I can find this picture, and I will open it up in Paint. Open in Open with Paint. Okay, let's make it bigger. That didn't make it bigger. All right, undo. Resize. Let's just make it 10 times as big. Okay, five times as big. There we go. All right, so we can draw on this now. So this particular battery right here, let me change to red. Need a bigger pen. Power's going through in that direction. This battery current is going through there. This battery current's going through there. And this battery current is going through there. So going around this track, imagine these are like cars on a racetrack. Going around this track, we've got let's just call some of the ones going clockwise. No, let's go counterclockwise is positive. So this one is going counterclockwise. So we're going to call that one +6. Go to the next one. This one's going clockwise. So we're going to call that -9. This one, counterclockwise. So we are going to be going +30. And then -9 because this one is going clockwise. So 30 plus 6 minus 9 minus 9 gives us what number? 36 minus, what is that, 18? I want to say that is 18 volts. Let's see how I did. Got 54. Got some 18s. Got a lot of 54s. I believe this one is 18. Yes, it is 18. So if you put 18, congratulations. Ah, my nose itches. Stop thinking about me. Okay. So yeah, so I hope you see now how the direction of current flow matters. All right, so this circuit, we actually have to work the whole thing to get the answer. So this will be the first time we work a full circuit, and this isn't that bad of a circuit. So let's select. Let's see how much better I can make a circuit with the line tool. So I'm not going to spend too much time making this line. This looks so much better, and it's only a little bit slower. All right, so let's get back to our pen. Look at our numbers. 10, 250, 6, and 6. That's a 4. All right, so we're going to use our chart. R total, I total, and E total. We're not to power. We're not going to worry about it. We know E total is 12 volts. All right, R1. I'm just gonna name these. I'm pretty sure this is how they're named on the question. But if they're not, work with me. Oh, we know R1 is 10 ohms. We know R2 is 250 ohms. At this point, you should know that resistance adds together. So we know we have an R total of 260 ohms. I don't know why I keep making a 4 instead of a V. Okay, so to find I total, we're going to do I total equals E total over R total. That's 12 divided by 260. Gave us 0.046. And that will give us 0.046 everywhere. Because current stays the same in series circuits. So now all we have to do is multiply across. So 10 times 0.046 is going to give us 0.46 volts. And then 250 times 0.046 is going to give us 11.54 volts. I did that by just subtracting 12 minus 0.46. But you can also 250 times 0.046, 11.5. This is because I rounded. So the voltage drop of R2 is 11.54. Somebody didn't get it. A lot of people also didn't get it, so you're not alone. So the answer here is 11.54. I'm so sorry I keep messing with my nose. It's tickling. All right, now that we have, okay, so find the unknown value V2. So V2 will be the voltage of R2. Luckily, in this one, we know we have 12 volts given to us. We have 5 volts and 3 volts, so that's 8 volts. We know we have 4 volts remaining. We don't have to do any special math. We know these 3 will add up to 12 volts, and we're missing 1. We're missing 4 volts to get to 12 volts. So we know we have to have 4 volts there. Okay. Power delivered in a DC circuit is the measure of amount of work done by the circuit per unit of time. So the power is one of the only universal. Power is the only universal value. Power will always add up to the total. No matter what type of circuit it is, powers will always add up to the total. So power is a great way to check your circuit against the numbers that you used. Just add up all the numbers and see if that is what you got for power total. And that's what this question's asking. The sum of the total power is equal to the total power. The sum of the power dissipated by each resistor is equal to the total power. So if you add up all the powers, you get the total. What would happen to a resistor if it was subjected to voltages or currents which caused it to dissipate more power? If it's only rated for so much power and you put more power to it, it's going to be damaged. Yes, true. Total power requirement in a series circuit is the sum of the powers So this one you have voltage and resistance. You can use any of the formula with voltage. So you can use this formula with voltage, resistance, and power. Or you can I wish I knew the hotkeys a little bit better. So for this one, you have resistance and voltage. You don't have I or P. What? Let me get the numbers. 36 and 72. Let's close that one. Don't save. Shit. So now you can either use ERP, E squared RP, to do P equals 36 squared divided by 72. That will give you your power. Or use 36 divided by 72, which is 0.5 amps. And then, so now that you have current, you can use I times E to get P. And you don't have to use really a calculator, because 0.5 times 36 is 18 watts. Next up, what would be the minimum wattage rating for resistor 2? So this one is just asking what is the wattage of resistor 2. And this is you'll have to work the whole circuit. Let me see how close we are to the end. Oh, I do want to work this one. So I'll work both of these. I apologize that this stream is taking a little bit longer than normal. Alright, so let's reset. Even though that was a beautifully drawn circuit. We're not going to take that much time next time. 180 volts, 27 ohms. Let's just load that open. Pictures. Where's the circuit that we're working on? Is that it? I feel like that's it. Insert. Insert's the one I want. Aha. That's how I need to do it from here on out. Alright. Yes, so we are looking for the wattage of resistor 2. So we've got we know we have 180 volts total. R1, R2, I1, I2, E1, E2, P1, P2. So we got 27 ohms and 18 ohms. We'll add that up because that's how resistance works. 27 and 18, that is 45 ohms. 180 divided by 45 is 4 amps. And since amperage is the same throughout the circuit, we got 4. Now 27 times 4 is 108. Well, that makes this one easy. That is 72. Because 108 and 72 adds up to 180. Now all we have to do is multiply I times E to get P. 4 times 180 is going to use the calculator. 720. 4 times 108, that's got to be 432. I'm not going to do that. You can 720 minus 432 and you would get your answer. I'm going to do 4 times 72. $288. Real quick, let's add this up. 2 and 8 is 0. 1, 8, 9, 10, 11, 12. 4, 5, 6, 7. 7. So these two add up to 720, and you get your answer. So 288 watts is the answer here. Let's see how we did. We got some people that got two. Some people got it right. That's good. Some people just punched numbers in. That's a way to do things. That's a way to be. In the circuit, the lamp is rated at 4 volts and 0.5 watts. What size resistor must R1 be in order to supply the correct current to this lamp? So, the way this one is worded is weird, but they do it intentionally. So let's erase. So what they're doing in this one is you kind of have to work backwards to get your answer. So let's paste from... I really should put these in a separate folder so y'all don't have to see all my folders of pictures. Alright, so here is our value, and let's pull in... Let's just rotate this a little bit so it's in front of me. Oh, damn it. Yeah. 3 weeks in, still perfecting my setup. Alright. Let us... So we know we have 9 volts total. We have 9 volts total. And we're calling E2, but it's really E of L1, P of L1. You get the idea. So we know we want the lamp to put out 0.5 watts of light whenever it receives 4 volts. That's what our goal is 0.5 at 4 volts. That leaves us with 5 volts to be dissipated by resistor 1. If resistor 1 dissipates 5 volts, then that will have us completely dissipate all of the voltage. So first, in all series circuits, you're looking for current. So because current's the same, so it's kind of the linchpin that holds everything together. So 0.5 watts divided by 4. 0.5 divided by 4, before I screw this up, 0.5 divided by 4 should be 0.125. So 0.125 Alright, so now we have all of our amperages. We have all of our amperages, and now we can find all our powers, we can find all our resistance, we have everything we need to solve this circuit. But just to jump straight to the answer, 5 divided by 0.125 is 40. 40 ohms is our answer here. Now you can divide the rest of this stuff out to get your answers, or to double check yourself. It's just multiplication and division is all you have to do. But so we got a couple people that did 40 ohms. Good job. Alright, we are running behind, so I'm going to go ahead and finish this and put in the new quiz. Launch new quiz. 6 and 7. This one won't be very long. Shouldn't take that long to do. Alright, and we will come back at 3:45 to do the second to last quiz, not the last quiz. I will see you guys then.